Good afternoon, everyone. Welcome to the course Coherence and Quantum Entanglement by Professor Anand Kumar Jha of IIT Kanpur. So, this is the first week of this course, and we will briefly discuss the course logistics and how we plan to proceed in this course. So, first things first, I am Radhika Prasad, a PhD student in IIT Kanpur, and my supervisor is Professor Anand Kumar Jha himself. So, I'm a student in his lab, and the lab is called Quantum Optics and Entanglement Lab, where we perform experiments and also formulate the theory to explain the experiments that we perform. So let us get started. First things first, the course logistics is as follows. So this is going to be a 12-week long course, and every week there will be a few lectures which you are supposed to watch, and after watching those lectures you will attempt a quiz, a short quiz, and this quiz will have 10 questions which will be MCQ type questions, and each question will carry 1 mark, so every quiz will be of 10 marks. And the aim of these live problem solving sessions is to basically solve some assignment problems which will be similar to the quiz, so that you will be able to solve the quiz problems on your own. So it is basically to help all of you. And these live problem solving sessions will be conducted by me every Saturday from 3 p.m. to 5 p.m. on this very Zoom link. This Zoom meeting that you have joined right now will be the same throughout the duration of this course. So every week you will log in at 3 p.m. on Saturday in this very Zoom meeting. And also there is a YouTube channel. So this YouTube channel, this is the channel where each of these live problem solving sessions will be uploaded, and also they will be live streamed on YouTube. So sometimes what happens is that when a lot of students join in Zoom, then due to some bandwidth issues or some connectivity issues, either the video or the audio quality is not that great. So in such a case, I would recommend the students to head over to this YouTube channel and watch the live stream over there. So, and also in case if you miss some particular week, some particular problem solving session due to some other commitments that you may have, then you can head over to the YouTube channel and watch the recording of that particular session which you would have missed. So please do check out this YouTube channel, and also you will find some other physics related content on this channel, and also the assignment problems and solutions for some other NPTEL courses over there. Okay, so this was about the course logistics, and we can now proceed to what we have set out for. So as you must have seen in the course, okay, someone is asking about doubts. So yes, you can ask doubts at 3 places. Let me just write that down over here. So what do you do if you have doubts? So the first step would be to ask a question in the forum. Ask a question in the course forum. So if you log in to the NPTEL course website, you will see a button at the top. Amongst other buttons, there will be one button which says ask a question. If you click on that, it will open up the course forum. So the course forum is basically a Google group, and you can post your questions over there. And once you post your question over there, then you will receive a response from one of the TAs, which is one other student is also there, and I am also a TA for this course. So there are two TAs for this course. Also there is a third TA. So two TAs will take live problem solving sessions. One TA is there doing the back end of this course, and also finally we have the instructor. So once you post a question on the forum, one of us, like one of the four of us, will try and solve your query as soon as possible. So that's the best channel to get your doubts clarified and to pose questions. So first step is to ask a question on the course forum. Secondly would be to ask in this Zoom meeting or on the YouTube channel. So you can post a comment on the YouTube channel for the respective week in which you have a doubt. That is second. And the third channel for doubt clarification would be to send me an email. So this is my email. But mind you, this is the last option that you should consider, because I may or may not be able to answer all your emails if you directly start bombarding with me with lots of questions on over email. So the most important out of this is definitely the course forum. You should use this as much as possible. And apart from that, you can try out the YouTube channel or send me an email. But this is only after you have posted your query on the course forum and you see that there is not much action happening over there. Then you should try out these other options. Okay, good. So now we can start. As you would have seen that there was a week 0 in which there were no lectures, but there was this preliminary quiz which is not going to be graded. So there were 5 questions in week 0, and this is just to basically set the tone for this course so that you are familiar with some of the preliminary information which will be required for you to understand this course better. So if you are able to answer all these week 0 questions, you are basically qualified to take this course. And if not, then you should probably reconsider your choice or try to build upon these basic concepts. Okay, so let us start with week 0. And how we plan to proceed is that for each of these MCQ questions, I will launch a poll in the Zoom meeting. So whenever I launch this poll, you will see a pop-up come in your Zoom meeting. So that pop-up will be the poll, and the poll will have options A, B, C and D, and you are supposed to select the correct option by clicking in that poll. And then once all of you answer the question, I will then discuss the correct solution and we will discuss the result of the poll. So I request all of you to kindly answer only in the poll. Please do not send messages in the chat box that okay, the answer is option A or option D or option C or B or whatever. So instead of putting it in the chat box, there is this dedicated poll for this very purpose. So please use the poll to answer the question. So just give me a minute. Let me start the poll for this particular question. Okay, so I have launched the poll for the first question. Let me read out the first question. The question says, for a particle of mass m and speed v, what is the de Broglie wavelength? By the way, this pronunciation is de Broglie, not de Broglie, as many of you might have learnt in your school. Okay, so all of you, please take about a minute to answer the question in the poll. Once all of you answer, I will then discuss. Okay, so let us now discuss the answer. The correct option is option C, H over mv. And let us quickly discuss this de Broglie wavelength and what these terms mean. So the de Broglie wavelength states that the wavelength associated with a particle, this comes from wave particle duality, is given as lambda equals h over p. So lambda is the wavelength, p is the momentum of the particle, which is nothing but equal to mass times velocity, or mv, and h is the Planck's constant. So this gives me lambda equals h over mv, and that's how option C is the correct option. Okay, so the first question done. Let us move ahead. Next question. The smallest packet of energy at any given frequency is called what? We need to select. I will restart the poll for all of you. Please select the correct option in the poll. This is a very simple question. It's just about nomenclature. So just take maybe less than a minute to answer. All of you, please attempt the poll. I see that some students are not answering. Okay, so the correct answer is option B, photon. Next question. An electromagnetic mode in the vacuum has wavelength lambda and is moving at speed c. What is the minimum amount by which its energy can be increased or decreased? Okay, so again, let us now discuss the answer. The correct option is option C, Hc by lambda. And this is because either absorption or emission is done by a photon which is the smallest packet of energy, as we saw in the previous question. And the energy of a photon, the energy is given as E equals h nu, where h is the Planck's constant, nu is the frequency, and the frequency is nothing but c over lambda, because c equals nu lambda. C is the speed of light, nu the frequency, and lambda the wavelength. So the energy of a photon is hc by lambda, and this is the amount by which the energy can be increased or decreased in an electromagnetic mode by either absorption or emission of photon. In fact, this is not just the minimum amount. The energy can be increased or decreased only in integral multiples of h nu, integral multiples of the photon energy. So you can absorb either one photon or two photons or three photons, or emit one photon, two photons, three photons, but you cannot have something like 1.5 photons. So only integral multiple of the photon energy is allowed. Okay, so moving forward, the next question is on photoelectric effect. Which of these is false about the photoelectric effect? So I have relaunched the poll. Okay, so let us now discuss the answer. The correct option is option C. In photoelectric effect, the bound electrons of a metal get ejected. This option is false. Remember that this question was about which of these options is false rather than which of these is true. So please note, please read the question properly. Some of you have selected some other options which are indeed the truth about photoelectric effect. So I believe you probably selected thinking that what exactly is photoelectric effect. But here we are supposed to select what exactly is not photoelectric effect. So option C is the correct option in the sense that it is false about photoelectric effect. So let us just quickly recapitulate what is photoelectric effect. So in photoelectric effect, a photon is incident on the metal surface and an electron gets ejected, And the energy equation for that is as follows. This is the energy equation. I will explain each of these terms. So what is h nu? H nu is the incoming photon energy. So a photon with energy h nu is incident on the metal, meaning it is having a frequency of nu. K max is the maximum kinetic energy that the ejected electron will possess. And in terms of electron volts, this is given as EV naught. Phi is the work function of the metal. Work function of the metal is basically the minimum energy required by the photon so that an electron is ejected. So this minimum energy will be written as h nu naught, where nu naught is the threshold frequency. So the frequency needs to be higher than nu naught, only then the electron will be emitted. And what is V naught? So minus V naught is the stopping potential. So in the photoelectric effect setup, what we have is a metal plate and a photon is incident on it, and then we have basically we have another plate which is kept at a certain potential so that the electrons emitted from the metal plate can be driven towards the other plate and we get some current out of this setup. Now if we keep the other plate at a potential minus V naught, then what we will observe is that there will be no photocurrent. So that is why it is called stopping potential. Okay, so we move on to the last question of week 0. After that, we will start with the current week, that is week 1. So this next question is, for an electromagnetic field with wave vector k and frequency omega, which of the following represents a field going to the right? So let me relaunch the poll. You can select multiple options in the poll if you feel multiple options are right. Okay, so let us discuss the answer. So there are two correct options in this case. Option A and option D. Now let us see why each of these options is correct. So the phase for the wave is the argument of the cosine, which is kx minus omega t. Now for constant phase points, if we look at the constant phase points, we see that for kx minus omega t to be constant, if t is increasing, then that means x should also increase, so that kx minus omega t, which is the phase, remains constant. So if we look at the propagation of the constant phase point, so if we have a wave like this, and if we look at, let's say, these points which are having the same phase, okay, and we see that if t increases, to maintain this phase, this kx minus omega t phase, x should also increase. So in this case, if x is increasing, that means the wave is moving to the right. So x increasing means that the field is actually moving to the right. Had it been kx plus omega t, then in this case we see that if t increases, then x should actually decrease to keep kx plus omega t constant, and this would mean that the field is moving to the left. Finally, we know that cos theta is same as cos minus theta. So whether you write cos kx minus omega t or cos omega t minus kx, they mean the same. I mean, the result will be the same. So that's how options A and options A and D represent an electromagnetic field moving to the right. So this brings us to the end of week 0. I hope all of you were aware with these concepts. If not, I believe now it will be clear. And please do try to read some of these basics, like what is photoelectric effect, how do you write an electromagnetic field, what are the Maxwell's equations, and so on, just to get like what is wave particle duality, and what is this de Broglie wavelength. Just try to read about these basic topics and concepts, which will create the foundation for this particular course. Now we can finally dive into week 1, and the questions are a little bit lengthy because you have to derive certain things, and basically this course will be very much derivation heavy. So you have to actually solve the equations and derive different expressions. It's not just very simple MCQ questions where you can actually get to the result by, let's say, eliminating the options or just by looking, just by sight. You have to really work out the problem by sitting with a pen and paper and do a page worth of calculations before you get to the final result. So let us start now. So this will not be MCQ because MCQ doesn't really justify. I mean, I have to derive these questions, so there is really not much point in writing down the options. So I have just let it be as a normal derivation type question. So let me read out this question to all of you. This is the first problem and it has two parts, as you can see, part A and part B. So the introduction to this problem 1 is: the mean of a random process x is defined as follows, which is integral of x px dx, where px is the probability density associated with the random process. The standard deviation sigma, which quantifies the degree of randomness of a process, is defined as sigma equals square root of x minus mean x whole squared. Suppose P1x and P2x are the probability densities corresponding to two separate random processes and are defined as follows. P1x equals 1 by a if x lies within 0 and a and 0 otherwise, and P2x equals 1 over b if x lies between a minus b by 2 and a plus b by 2 and it is 0 otherwise. Here we are taking a greater than b. The question is, verify that the above two probability densities are normalized, and part B is, calculate the mean and the standard deviation of both the random processes. Then plot P1x and P2x as a function of x and show the corresponding mean and the standard deviation on the plots. So it is a pretty lengthy question, and it's very straightforward in the sense these expressions are given for mean and standard deviation. All you have to do is plug in these expressions for P1x and P2x in these expressions for mean and standard deviation and just do the algebra for the same, and you will get to the result. I'll give you about a minute to at least start working on this problem, after which I will start working as well, and then you can check whether your starting point was correct or not and how to proceed further with the question. So just take some time to think about this question and just try to write down the relevant expressions and equations, and just try to at least get a head start before I actually solve it out for you. Okay, so I believe all of you have got some idea of how to approach the problem, and let me also start solving side by side so that you can check whether you are heading in the right direction or not. So let me start with option with the part A. For a normalized probability density, what do we mean by normalization? We need to know that before we can attempt problem A in the first place. So a normalized probability density is a probability density for which the integral over the entire space is equal to 1. Now what do we have? We have P1x equals 1 over A if 0 less than equals x less than equals A, or else it is 0. So let us plug in this integral over all space. So integral P1x dx over all space, P1x equals 1 over A but remember this is 1 over A only for 0 to A and it is 0 otherwise. So from minus infinity to 0 it is 0, from A to infinity also it is 0. So this is equals integral 0 to A 1 over A dx. 1 over A is a constant, we'll bring it out of the integral. So integral 0 to A dx, integral dx is nothing but x and it's a definite integral. So from 0 to A, so this is nothing but 1 over A times A minus 0, which is A by A, which is equal to 1. Hence P1x is normalized. Next, let us check for P2x as well. P2x is 1 over B if A minus B by 2 is less than equal to x, which is less than equal to A plus B by 2, or else it is 0 and we are taking A greater than B. In this case, again we will evaluate this integral over all space. Again 1 over B is a constant, we'll bring it out. It's just similar to what I did above, only with different limits. And I can cancel out some terms. So A by 2 minus A by 2 cancels out. This leaves me with 1 over B, B by 2, minus minus plus, so plus B by 2, which is 1 over B times B, which is nothing but equal to 1. So this implies P2x is also normalized. So this completes part A, wherein we have evaluated the integral of p1x and p2x over all space, and we show that they are indeed normalized. Now we can move over to part B, where we have to find out the mean and standard deviation. So mean is given as follows. It is integral of x px dx. So let us start for p1x first. Okay, before proceeding, does anyone have any question up until now? If I'm going too fast, do let me know. Stop me wherever you have a question. Either you can put up the question in the chat box, or you can just directly unmute yourself and ask the question. Okay, seems like people are fine with this up until now. So I can safely proceed. So mean for P1x is a by 2. Next, let us evaluate the mean for P2x. Again, some terms will get cancelled out over here. So let us see. A squared by 4 minus a squared by 4 and b squared by 4 minus b squared by 4. Again, we see that the mean for even P2x turns out to be a by 2. So the mean for both P1 and P2 are the same, which is a by 2. Now let us find out the standard deviation. So this is the definition of standard deviation. I will just try to simplify this. So that our calculation would then become easier. So this expression finally reduces to square root of mean of x squared minus square of the mean. So we will be making use of this final expression to evaluate the standard deviation. Again, let us start with P1x. Let us find the mean of x squared because we have already found out the mean of x. This integral is also over entire space from minus infinity to plus infinity. If anyone has any doubt, please feel free to ask. Okay, someone is asking why I have put 0 to a in this limit. Because this probability density is valid only, it takes non-zero values only when x is between 0 and a, and it is 0 otherwise. So integral from minus infinity to plus infinity over the entire space will yield non-zero value only within the limit 0 to a. So a squared by 3 is the mean of x squared for P1x. Let us evaluate for P2x also. So a plus b whole cubed is nothing but a cubed plus 3a squared b plus 3ab squared plus b cubed. And a minus b whole cubed is a cubed minus 3a squared b plus 3ab squared minus b cubed. Again, a lot of terms will get cancelled, so a cubed gets cancelled. Similarly, 3ab squared also gets cancelled. Now we have found mean of x squared for p2x also. So finally we can actually evaluate the standard deviation. So once again, for p1x, the square of standard deviation, that is the variance, sigma squared is also known as variance, so this is the variance for p1x, sorry, the standard deviation for p1x. Now similarly for p2x, again we see that this a squared term gets cancelled out. And now we see that even though the mean was same for both p1 and p2, the standard deviation is different. So I hope everyone has been following up until now. Before we proceed to plot, please take a minute to see what exactly we have done up until now. And if you have any questions, please feel free to ask them right away. Okay, so someone is asking as to uh, how I got this expression for standard deviation. So standard deviation is defined as follows: sigma is square root of the expectation value of x minus mean x squared. Now when I expand this x minus mean x squared, I get x squared plus mean x squared minus 2x mean x, and then we have this expectation value bracket around it. So when we open this up, and how do we open this up? This is because expectation of alpha plus beta is nothing but expectation of alpha plus expectation of beta. So we can open this bracket. This gives us expectation of x squared, and also if you have expectation, that doesn't make any difference, it is still equals expectation of x. So that's how we get this expectation of x squared. And similarly, that's how we get this minus 2 expectation x. And so this is basically minus 2 expectation of x squared. And so expectation x squared minus 2 expectation x squared is minus of expectation of x squared. That's why we get this final result. Okay, so now I think we can proceed to making the plot. Let me draw the axes. Okay, this doesn't look straight enough. Yes, that's better. Okay, so here I'll plot p1x, and this point, let us say, is 1 over a. This is the origin 0, and so we have a plot over here which looks somewhat like this, where this is a, this is the x-axis. Yes, now mean is over here, which is a by 2, and standard deviation will be somewhere over here, which is nothing but a over root 12. So let us just see what the mean and standard deviations are. So mean is over here, we have evaluated, it is a by 2 for p1x. So that's my mean right there. And standard deviation we have evaluated over here, and for p1x the standard deviation is a over 2 root 3, which is nothing but a over root 12. So that's over there. This is for p1x. Now let us do the same for p2x. Again, let me draw the axes. So this is for p2x. This is my x-axis, and let this value be 1 over b. So it is 0 up until this point, which is a minus b by 2. Then from here up until a plus b by 2, it is this, and then 0 ahead. And again we have the mean, which is a by 2, and then the standard deviation, which is b over root 12, and note that a is greater than b, a greater than b. So that's my mean and that's my standard deviation. So that's the plot, and this completes the first problem. So once again, let us recapitulate what we did in this first problem. So firstly, we verified that the probability densities are normalized by evaluating the integral of the probability density over the entire space, and if it turned out to be 1, then that means it is normalized. And then we calculated the mean and standard deviation using these expressions given over here. So this is the expression for mean, and this is for standard deviation. And after calculating the mean and standard deviation, we also plotted them on the graph. So just take about a minute to check your answers and see if you are able to understand each of these steps. Okay, so seems like everyone is comfortable and we can move ahead to the next question. This question has 3 parts, and again it is similar to the first question that we did. Let me read out the question for all of you. One of the most often encountered random processes in optics is the Gaussian random process. The probability density Px associated with the Gaussian random process is given by Px equals 1 over root 2 pi sigma exponential of minus x minus mu whole squared over 2 sigma squared. Verify that the above probability distribution is normalized. Find the mean, which is also known as the first moment, and the second moment of this distribution. Also calculate the standard deviation. Calculate the third and the fourth moments. Do these moments yield any new information about the process? So these are the 3 parts, and as you can see, they are pretty much identical to problem number 1 that we did, in the sense that part A and part B are exactly the same. We have to verify that the probability density is normalized, and also we need to find out the mean and standard deviation. After that, the part C says that we need to find out even the higher order moments, which is the third and the fourth moment. So I hope you can see the connection between this problem and the previous problem, and that they are similar in nature except for the expression for the probability density that we have now. This expression is for a Gaussian random process. So take about a few minutes to get started with this problem before I start solving it for all of you. Okay, so I think people have started working, and I will start solving it now for all of you. So let us start with part A to check the normalization. Let us make the substitution x minus mu over root 2 sigma equals t, which implies dx over sigma root 2 equals dt. So this gives me and this integral is nothing but root pi, so this gives us 1. And why? Because this comes from the Gaussian integral. So this is the Gaussian integral. And using this, we clearly see that px is normalized. Moving over to part B, we need to find out the first moment. First moment is nothing but the mean. It is given as follows. So mean is also known as the first moment. So let us find out the mean for this Gaussian random process. So let us take sigma and root 2 pi outside. It's a constant. Again, we will make the same substitution, that is x minus mu over root 2 sigma equals t, which means dx over sigma root 2 equals dt. So x is nothing but sigma root 2t plus mu and then e to the power minus t squared. And we get this because this integral yields 0. Why? Because since t is odd and e to the power minus t squared is even, and what we have is even, we know that odd into even function is an odd function, and we also know that integral of an odd function from minus infinity to plus infinity is 0. So this gives us mean is equal to mu, or the first moment is equal to mu. I hope this is clear. If I am going too fast, please stop me in between. Okay, someone is asking how I have made the substitution. So see this dx and this sigma root 2, dx over sigma root 2 is basically equal to dt. So this part is coming from here. And also this part is coming from here. Okay, so this part is clear. First moment is done. Let us now evaluate the second moment. So what do we mean by second moment? Second moment is nothing but mean of x, the expectation value of x squared, which is given as follows. So let us now evaluate the second moment. Again, taking the constant out of the integral. We will again make use of the same substitution. This is the same substitution that we will use again and again in Gaussian random processes. X is again sigma root 2t plus mu. This time it will be raised to the power 2. Now let me expand this term inside the square. Now, as seen earlier, this integral will give 0 because it is integral of minus infinity to infinity of an odd function. Why it is odd function? We saw it earlier over here that t is odd, exponential minus t squared is even, and product of an odd and an even function is odd function. So this gives me the following. And this is the Gaussian integral. This will give me root pi as seen earlier from here. And this root pi in the numerator denominator cancel to give 1. Now this comes because integral of minus infinity to plus infinity of an even function is nothing but 2 times integral 0 to infinity of the same even function. Also, let us make a substitution t squared equals u, which implies 2t dt equals du. So t squared is u, e to the power minus t squared e to the power minus u. And dt is du over 2t. So du over 2 and t is nothing but root u. So this 2 cancels out with this 2 over here. This is gamma function of 3 by 2. And what is a gamma function? So a gamma function is defined as follows. And gamma function of half is root pi. So using this, again this root pi cancels out, 2 cancels out, which is sigma squared plus mu squared. That's the second moment. Standard deviation is square root of x squared minus expectation of x squared minus square of the expectation of x. So this is sigma squared plus mu squared minus mu squared. So mu gets cancelled. This gives me nothing but sigma. So it is important to note that in this expression over here, mu is the mean and sigma is the standard deviation. This sigma over here is standard deviation. So this completes part B as well. Now we are left with just the last part, which is finding the third and the fourth moments. So the third moment is defined as expectation of x cubed Again, we'll make use of the same substitution. I'm not writing it again. We have already seen this substitution quite a lot now. Now, we can easily see that this first and third terms, which are odd in t, integrate to 0 because it's integral of odd function from minus infinity to infinity. Why? Because t cubed is also odd, t is also odd, and e to the power minus t squared is even. So odd into even is equal to odd, and integral of odd from minus infinity to plus infinity is 0. So these integrate out to 0. Now we have seen from earlier questions that this integral is root pi from the Gaussian integral, and this we just saw above here in the second moment. This is this integral right here, and this integral evaluates to root pi over 2, which is over here, which is nothing but gamma 3 by 2. So this integral is root pi over 2. So putting in, we get So after cancelling out the terms in numerator and denominator which are common, we get 3 sigma squared mu plus mu cubed. This is the third moment. Let us also now find the fourth moment. Fourth moment is expectation of x to the power 4. Again, we are making use of the same substitution that we have already seen multiple times. Again, out of these terms, the second and the fourth terms integrate out to 0 because they are integrals of minus infinity to infinity of odd functions. Why? Because t cubed is odd, t is also odd, and e to the power minus t squared is even. Odd into even is odd, and integral of odd from minus infinity to plus infinity is 0. Okay, let me just bring this a little bit down so that it doesn't really interfere with the line above. Now this I know integrates to root pi from the Gaussian integral. This I know is gamma 3 by 2, which is root pi over 2. And again I will make the substitution t squared equals u, which implies 2t dt equals du. From this only we get this t. From this t we will get, now we'll put in and we'll get u. So let me do that. Also I'm using that integral of minus infinity to infinity of even is 2 integral 0 to infinity of the same even function. So that's where this 2 is coming from. because t to the power 4 is even, e to the power minus t squared is even, and product of even functions remains even. Now this is from the definition of gamma functions, gamma 5 by 2, which is nothing but 3 by 2, gamma 3 by 2, which is 3 by 2 into root pi by 2, because gamma 3 by 2 is root pi over 2. So this gives me the following. Now you can see that sigma and mu are present in first and second moment for this Gaussian random process. So for the Gaussian random process, the third and the fourth and any higher order moments do not contain any new information which is not otherwise provided by the first and the second moments. However, if we do not have a Gaussian random process, then this third and the fourth moments have special names and special significance. So the third moment is known as skewness. So what is skewness? Let me draw. So a Gaussian random process. Okay, wait. Let me try and draw neatly. Okay, I'm not sure how good of a drawing I am doing. Does this look like a Gaussian? I don't think so. So my drawing is becoming worse. Let me just forget about this. Let me just draw something and please assume that this is a Gaussian. Okay, so if this is a Gaussian random process, and this is some other process, and this is another process. So as you can see, this central one is a Gaussian random process and it has a skewness of 0. It is symmetric. The left one is having a skewness which is negative, and the right one is having skewness which is positive. So skewness is basically telling you the amount of asymmetry with respect to a Gaussian random process. Similarly, the fourth moment has a name which is known as kurtosis. Again, let me draw for kurtosis. Okay, let me draw this in a different color and this in a different color. So for kurtosis, Again, let me say I have a Gaussian function. My drawing is going from good to bad to worse. So this is the Gaussian function. And kurtosis basically measures the tail heaviness, how much tail is there as opposed to a normal Gaussian function. So this is kurtosis negative, and this right here is going to be positive kurtosis. So you can see that the green one has significant contribution from the tails, and the purple one does not have as much contribution from the tails. So this is how these functions compare to the Gaussian, which is the yellow one. So that's what third and fourth moments give. Although in the case of Gaussian random process, they do not contain any new information. So this brings us to the end of week 1. We will meet again next Saturday, same time 3 p.m. to 5 p.m. On the same Zoom link. So from my side, today's class is over. If you have any doubt, please feel free to unmute yourself or type it in the chat box. Just to recapitulate what we have done. So in this week, we just saw some simple concepts for week 0. Basically the Broglie wavelength, photoelectric effect, what is a photon, and how do we see electromagnetic field which moves to the right or to the left. Then we solved some problems wherein we had to check whether the given probability density function is normalized or not. And then we went ahead and found the mean and standard deviation for those random processes. And also we calculated the higher order moments. Then we saw what is a Gaussian random process. So this was all about week 1. Okay, someone is asking in the chat box, what is a gamma function? Okay, so I have defined it over here. You can check out any mathematical physics book. For example, a mathematical methods book by Erwin Kressig. That's a good standard book to learn what these functions are, this gamma function. So for now, this gamma function is defined as follows. You just take it as a definition. So gamma function is integral 0 to infinity x to the power z minus 1 e to the power minus x dx. This is gamma function of z, where z can take any value. So gamma function of n plus 1, where n is some integer or maybe not even an integer. Basically gamma function of 1 plus any number is that number n times gamma function of n. That's one property. Again, you can check the standard references for mathematical physics standard texts. You will be able to find the proof for each of these properties. And also gamma function of half is root pi. So I have used these as properties. You can check out the standard mathematical physics textbooks or to know more about these gamma functions. In fact, you can even check out Wikipedia as a good starting point for gamma functions. So what this is known as, let me write down. This is known as gamma function. I hope that clarifies the doubt. Okay, any more questions? In case you have further doubts and questions, as I mentioned in the beginning of the lecture, you can ask a question in the forum, or you could put it up as a comment in the YouTube channel or send me an email. Also, for those of you who joined late, here is the link to the YouTube channel where each of these live problem solving sessions would be uploaded and in fact also live streamed. So just in case if you miss some parts of it or if you miss a particular live problem solving session, you can head over to this YouTube channel. Okay, so that's it from my side. This is the end of today's lecture. If you do not have any more questions, you could leave the Zoom meeting. Okay, so bye bye. See you next week, next Saturday.